ICR. He secured the top rank in the PG ICR examination during his postgraduate studies. Subsequently earning a GRF, he continued to excel academically, gaining admission to the prestigious NDRA Karnal Institute with top rank. Throughout his academic journey, Mr. Mehta demonstrated exceptional proficiency in competitive exams, having successfully cleared many exams like GATE exam, UGC NET, ICR NET, CSIR NET. Earlier, he was appointed as an assistant professor at Rajasthan University of Veterinary and Animal Sciences, Bikaner, currently serving as an assistant professor and in charge of the Department of Dairy Engineering. He plays a pivotal role in shaping the future of dairy engineering education research. Mr. Mehta has significantly contributed to the field through his research endeavors. He has published several research articles, review articles in many national and international journals. With this word, I welcome Dr. Sumit Mehta for his lecture. Over to you, sir. Please.
Thank you, ma'am. I hope the slides are visible now. Firstly, I want to thank all the organizing committee and the BASU faculty members to make me part of this summer school program. Now I want to start my topic on current development, dairy science and technology summer school program, which is machine vision and image analysis systems in dairy and food sector. So myself my name is Sumit Mehta. I am working as assistant professor in dairy engineering department. Also, I'm in charge of the dairy engineering department, College of Dairy and Food Technology, Basti Jaipur, working under Rajwas University. So we will start the machine vision and image analysis system introduction first. Then we will know the basics of these terms, then how it is works in the dairy and food sectors, and what is the role of these things in our sectors. Something, our first appearance or first things we want to see is the color. When color visual textures affect the influence customer purchasing decisions. Sorry, wait a minute. Okay. Sorry for interference. So color conveys information to consumer about a product's sensory qualities or about primary brand attractive such as premium, natural or healthy in many food product categories. We can see in the ice creams, the color is mainly affecting the newest generation, the kids. They are more demanding the products which is very colorful or looks very attractive. But the color conveying system is not only about the attractiveness and the customer purchase. It also shows what is the quality of the product, like in ghee and other. In the some of the products, the black color shows the defect of mottleness and other things. So quality can be changed, and we can see the changes through the color in the product. So we require the color measuring instrument and the changes between these instruments are regularly we have to see. To obtain a reliable objective color assessment due to subjective perception of color and its variation from observer to observer. First of all, we have to train our instruments. We have to feed the data in the color instruments to make the instrument reliable. If it is going on a certain data which is not quietly impactful for us, it is not working in a certain areas. So these computer or machine visions is one of the best option for automated, non-destructive and cost-effective methods. So basically, we are producing some of rays, reflectance, transmission, and other properties will show what are the color properties of different products. So it is completely a non-destructive process. We did not break the product, destruct the product. We required only some of the grams of samples to analyze it. It is very cost effective because the processing of the whole quality analysis as well as the labor is very low, only 1 or 2% required to analyze, but it should be the skilled one. So most of the color measuring instruments, when we are talking about it, like it lacks in the temperature control systems. We are controlling the parameters which is changing the colors, but we are not integrated the systems which is completely combined with the temperature system. So we have to in the process control we have to first measure it, feedback, give to the feedback system, and we have to control the temperature systems. Like butter and ghee, there are 6 to 7 agroclimatic zones in India, and everywhere we are um, storing the ghee in a atmospheric temperature. So the temperature of the product like ghee changes, the color it changes at different climatic zones. Like in the north regions, the winter and the temperature is very low, so the it looks in the solid side and the refractive index is changed. As well as if we are going down in the countryside, so the semi-solid consistency and liquid consistency comes into the ghee, and the product color is changed with the consistency of the product. So we can't say that the yellow color ghee and the whitish ghee is quite quantitatively or qualitatively good, but we have to think about it that we can control the temperature of the system through the, and we have to establish a data where the temperature calibrated systems show the quality parameters of the different dairy and food products. So first, the why we are using the computer vision. It is looks like our eyes, the human eyes. It controls like our brains. It reflects the signals into the our systems. Then it transmits the systems and gives the details to our other body parts. Same as in computer vision system, the image is captured. Then it is analyzed by setting the various parameters. Then it is giving a signal or a control mechanism to other parts of the industrial system. So it is very accurate, and the accuracy is very high, as well as it is very fast in terms of giving the results. When we are analyzing the data, which is very big and very accurate, it will give you the whole data set, which will be effective for the next generation. I have already told how it is cost effective in terms of the production and other things. So what is the computer vision system? It is also known as a machine vision system or computer imaging system. It is the science that develops the theoretical and algorithmic basis by which useful information about an object or scene can be automatically extracted and analyzed from an observed image set, or image sequence. The basic thing we have to give to the computer vision system is the feed. Then it is analyzed. We have to code it the main code which will circulate the data according to our algorithms. So in this branch, the artificial intelligence techniques deal with simulating human visions. So how it looks. So basically, the major part in the computer vision system is a illumination chamber where all the light sources combined and reflect the image into it. Then the value of the image will be got through the sensors. Basically, in the machine vision system, use the different camera angles and other things. The frame grabber or digitizer convert the signals into analog to continuous systems, and the computer monitor and computer system analyze the whole algorithm, and it is shown in the data representation on the display monitors. So the sensors, it is analogous to the human eyes. The eyes will act as a sensor in our body. The illumination system is outside light source, which is the natural light, the artificial light in relevant to the human. The frame grabber is our brain, and the result is our body parts. So the camera and frame grabber are joined together to form the digital camera. Use of digital camera eliminates the need to use a frame grabber in the computer. And cameras are combined and getting an integral part, which is getting a image signal directly through it. The image is digitized in the camera and sent to the computer for further processing. In the modern computer imaging system, do not need a separate monitor either. It is processing there only. So image can be displayed directly on a high resolution computer monitor. So there are the different image sector. In somehow it is given the gray, and somehow it is colorful one. So when we are setting the some of the parts of the different computer vision system, it is showing the result in the gray and other one. So basically, image recognition system in divided into three categories, like image acquisition system, image processing system, and image understanding system. But we also use the first steps, very first step before starting from the image acquisition is the processing of the image. We have to give some of the data, or we have to recalculate the image sizes, and we have to frames. Then it's called as a image pre-processing. We have to deal with the noise. We have to remove the noise from the images. So in image acquisition, it is deal with the such issues just like components as illumination, cameras, and digitizers. Where image processing steps encompasses pre-processing, segmentation, and feature extraction. And the image understanding part consists of image recognition and interpretation. So first we are going on the image acquisition system. The digital images, it is a spatial representation of an object or scene. It comes in 2D where it is come on a plane of X and Y axis. Most of the now we are going on a modern era, we are analyzing the 3D objects. But if we are analyzing the 3D objects by using the 2D cameras, we have to analyze the picture or set an algorithms to analyze the things in a 3D. We have to set the resolutions of the 2D array, like the most commonly used cameras have a special resolution of 512 into 480 or 640 into 480. This resolution used through the computer systems when the main camera click the pictures. For best results, it is important to make the specialization of the camera to that of the frame drivers. If we are fixing the same thing in a same frame, it will give the better results. Otherwise, the sum of the metrics or parts of the images will be not rectified all the details or compared from the adjacent components. So some of the images are the monochromatic. When we are talking about the monochromatic image, it will show the images in the gray level, and some of the image analysis systems like RGB, red, green, and blue, and HSI systems, hue, saturation, and intensity system works on that. We have to control the 8-bit integer and convert into the binary codes or other different source where gray levels can be measured. So gray levels can be measured into range of 0 to 255. So next part of the image acquisition system is the illumination. If there is no source of the illumination, there is no picture or no click picture, we will be not getting any result. So illumination make an important part into the image acquisition system. We use some of the different sources for the illumination, like LEDs, bulbs, quartz bulbs, and other LCDs. But the main factor is the frequency or resolution or aperture size of these things, which combined with the camera settings. If we are setting in frequency like our voltage frequency is 60 hertz, so if our frame rate is less than this 120, it will get the shutterness, or like it will come blink in every second in every frame. So it will be high chance we'll capture a dark image or a bright image, because in every 1 second the lights will get turned on or off in the AC generators. So the image will be in a part of second will be dark, and one part will be give us a lightest image. The prerequisite for any vision application is that the feature to be examined can be seen in the image. So well-designated lighting and illumination system can assist in accuracy and success of image analysis by enhancing image contrast. In good lighting will improve feature discrimination, reduce processing time, and reduce processing hardware requirement. As I have told, after the acquisition system, pre-processing of image can be done, where we do the analyze the image, what are the segmentation we have to analyze, and what can be the unwanted part we have to remove from the image. So illumination, if the illumination is very low, we have to give some extra lights through the contrast, brightness, and other parameters. But if the illumination source have the quite brighter side and giving the values according to our desired one. There is no need to make an pre-processing part of the pre-processing of image acquisition system. In illumination consists of selecting appropriate light sources and identifying suitable configuration for the light sources so as to obtain the highest quality image. If we are using the quartz lights, so basically we'll be developing a temperature factor also in the image processing system, which can be helpful for the product processing. And if it is not desired in the other things, it can make an unwanted errors in the image signal processing. So some of the different light sources like quartz and halogens, metal halides, xenon, and high pressure sodium are more typically used in large scale. It is the image showing the bulb. This bulb contains the gases which will make an environment to light these quartz bulbs. If basically the nitrogen and other helium gases are appropriate in the bulbs, which will be non-reactive to the substance of which will be act as a main lighting source. Same as in component fluorescent lamps, CFLs. This fluorescent typical lamp consists of a low pressure mixture of mercury and a rare gas like argon. Light source around 540 nanometers and 620 nanometers of the visible range collect through the CFLs. When we are talking about the LEDs, light emitting diodes, it is based on the semiconductors used, which is covered the frequency of 380 nanometer to 700 nanometer. Same incandescent bulb, which is basically we are using in the last decade. These bulbs has a tungsten filament which is heated when the current is conducted through it. Basically, the first and fourth one has changed the bulb and the filament part and the gases. Otherwise, the principle is behind these two lighting sources are same. So in most lighting arrangement can be grouped as either front lighting or back lighting. So these are the two different lighting methods. If we are getting a image from the front side, so the shadow will be appeared on the back side. Same as if we are getting a light from the back side, the shadow will be on the front side. So how it is, we have to eliminate the light source arrangement. It is depend on the what is product and what is the parameter which is we have to analyze. Like the front lighting option is best suited for surface characteristics of an object, while back lighting is best for subsurface features. If we are penetrating the substance and we have to analyze the properties which is penetrate the surface, which will be so backlit lighting is best for these parameters. In backlighting, Guna Shekhar examined internal stress cracks in cone kernels and apertures and through detected water pores in apples. So our basic part which will be getting our feed signals is the camera. The camera is the sensor of computer imaging system used to capture image information. It is functions similar to eyes in human vision. Charge coupled device cameras have been used for nearly all computer imaging applications. So these CCDs have been many development based on the technologies. These recently complementary metal oxide semiconductor technology has been introduced many varieties of black and white and color cameras that is commercially available on different shops. A black and white cameras will suffice for food quality evolution attributes unrelated to color. Now we calculate dimension, shape, geometrical attributes which can't be calculated through the simple parameters in the physical array. We calculate these dimensions through the camera system. Like we have to calculate the uneven size or uneven area of any product. So we can get an image of that and we can analyze through our processing systems. To evaluate color or color related attributes, an appropriate color camera should be selected. So these are the some of the camera settings which should be done before the camera angle setting. We when we are talking about the image scale, it should be based on the formula of Z root 3FB, where F is the focal length and baseline and P is the pixel pitch, sigma Z upon P. It is showing the distance to object using approximation formula. in this chamber, where the lighting source should be arranged and where the camera should be arranged, we can get from this formula. Then the step size, which is showing the maximum step size. So the thumb rule is that 20% width of the surface from the previous image, and consider complex object geometry where small dash lines for complex surfaces are done. So camera and lens settings, we require the large sensors for cameras, that is better than small one. Calibrated cameras better than non-calibrated system, and the lens are wide angles is better than narrow angles. And when we are talking about the exposure size, focal length, and other parameters, we have to set according to the what will be the exposure, like product having getting changes in a very few seconds. We have to fix short exposure time, and focal length will be set according to the distance between the product and the cameras. So these are the following parameters which are suitable or critical when selecting a suitable camera. Which resolution is required in camera, where we talk about the 540 and 480, 720 and 1080. So there is a signal to noise ratio is there. If the signal to noise ratio is low, then it is good. And if it's producing the high noise, so we have to make a pre-processing section. And after that, the signal output, we have to set a signal output which will becomes and gives the 4 milliampere to 20 milliampere signal. And the illumination, the high illumination will reflect and make the surface like greasy, and same properties like grayscales and silver image will be producing if the high illumination is there. Then the signal will be converted by the A by D outputs, analog or digitals. We convert our signal analog to and give it in a digital way, where our parameters which will be measured, we want to measure, and desired set values will be come into the computers. If the number of cameras are installed on the setup, the image will be look good, and the images when can be combined through the different cameras and give the better results at the same time or simultaneous processing. The frame grabber's basic function is a digitize is to computer an image from a camera so that a computer can access the image. Generally, a frame grabber takes an analog video wave sample it and specific internet translate the information into a digital form, which is stored as an array of picture elements, which will be called as pixels. So the following describe the critical feature to be considered selecting a frame grabber. It is more an IC in the system which convert the signals. It gives the video inputs analog to digital capabilities, signal handling, conditioning, system architectures for integration, with stillness characteristics. So in image processing, the steps show the image acquisition system. Now pre-processing, where we remove the unwanted signals, then image segmentation, feature extraction, and classification. So in image processing system, the basic step is the pre-processing, segmentation, and feature extraction. The purpose of image pre-processing of image condition is to enhance the quality of acquired image. Image pre-processing steps include one or more of the following, like noise reduction, geometrical corrections, gray level corrections, and correction of deep focusing. We make the different images homogeneous. Every single image should be looked in a same size, same dimension, so we can compare the different images. Otherwise, it is very difficult to get same varieties or same properties for the different images. So in image segmentation, the segmentation or partitioning a composite image into component parts or object property segmentation is very critical. Like we create the matrix. Basically, in the most of the segmentation systems, we divide the whole images into 3x3 system, 2x2 system, 4x4 systems, and we calculate each properties, compare the each properties from the very side matrix cell. The feature extraction step is the key in the deciphering the required image data from the composite image information. So after that, we come into the color image processing, where color is an important property of biological and food products. Color variation plays a major role in quality and digital evolution. Modern computer imaging systems are capable of acquiring and processing color images. The basis differences between a gray level and a color computer imaging systems are in the camera from gray bursts and display on it. Main thing in the color imaging is processing is that if we are producing data and on a wide level, so it will be act as a pre-data for the next generation. We will calculate the sum of the data. It will be set the basics for the color image processing. Some of the scales we will generate according to our specific product. Some of the general scales are there which will be pre-established. We have to analyze the product to our requirement. So we have to set different color image processing systems. We have to set different color image processing scales. We have to talk about the color coordinates, where we will calculate the image intensities and other things. The color computer imaging system represent color information in terms of color coordinates. Several types of color coordinates are found in the color theories. These theories are RGBs, SSI, LUV, XYZs. The extension used for color image system, basically RGB and SSI are the basic parameters or scales which is used. Some of the indices were used, like in our dairy sectors, we use the whiteness index, yellowness index, and sometimes for the mallard brownings, we use the redness index for the product distinguishing. Each color coordinates has three components. The combination of these components produces a color images. Like in RGBs, the differentiate between basic colors we did, like red, green, blue, and HSI, hue, saturation, and intensities. The three components will work together and give a signal which will be processed the whole image properties which will be vary in the different images. Like the instrument, we have to calibrate the image analysis system or computer vision system. Like in the pH scale, we calibrate the pH system into the three different pH setups, like 3, 7, and 10 pH liquids we used and calibrated in the whole range of 0 to 14. Same as if we are talking about different different parameters which we have to analyze, we have to show the all range to the system, which will calibrate according to these charts. These charts will establish before the production of the main product. We calibrate and minimize the error if thing like in the 13 number, it is the blue color, and if slight deviation is there, we reduce the error by adding or subtracting the values. The addition or subtraction will change the color. Everything has an intensity or other parameters. If we are setting the intensity in the color levels from visible range 300 to 720 nanometers, it comes like our rainbows with your things V to R. The 720 or the highest number will be calculated as the red color, and lowest will be the violet. So in the RGB, the three color components are the primary fundamental colors, red, green, and blue. Different combination of these primary colors produces various secondary colors. Same as CIE use the spectral primary systems. We can convert the RGB values and CIE into each others by using the formulas, where light is generated by a monochrome light source range of 700 nanometers for 35 and 546. These are the standard wavelengths used in the CIE scales. The RGB color coordinate system is commonly used in televisions, color cameras, and color display monitors, where RGB cameras and monitor have been used for computer graphics because RGB is a good system for generating and displaying image. Same, if we are computed the RGB system, we can directly calculate the I divided by the values of RGB by 3, where we calculate the hue, which is defined as the attribute of color perception by means of which an object is judged, like red, yellow, green. It is the basic RGB colors which is shown through the hues. Then we choose the intensity of the, if we selected the red color, second step is intensity. How much intensity it is in the lighter side, it is in the darker side, which show the intensity. Then saturation, that attributes of color perception that express the degree of departure from gray to the same lightness. Means the value from the gray, it is how different. The subtraction will be show the saturation of the same product. These are the sum of color scales we use in the CI Lab, Hunter, RGB, CI XYZ, LUV. These are the name, but the statistical formula is different somehow in the CI XYZ, LUVs, and YXY. Same we use some of the indices, whiteness index, lightness index, redness, yellowness, gray level, darkness index. These are the names. We basically use the intensity or wavelength and some of the parameters to create these whiteness indexes. These these diagrams shows the how the RGB wheel, RYB wheel is uh, getting the parameters of different variables. We can convert the RGBs to SCBs by this is the volume of creating of blue, red, and green, and this is the diamond shape, which the dimension of all these dimensions show the saturation. These dimensions show the hue, and other dimensions shows the value in the hue systems. So what we done in the feature extraction, a see we can see the first image. Where is the real image? First, we have to binarize image. We have to minimize the errors. Then we convert whole image into a image thinning system, which will analyze only the features, only shape feature. Like this is the whole thick image. Will convert this image into the thinning systems, and finally we have to analyze the shape feature extraction. So same as for the different kind of rice, we can analyze and sorting of, we can done the sorting of the different image. We can sorting of different rice sections through the getting the image. We have to take the RGB image, then convert into the binaries and remove object from boundaries and remove noises. Then we can reconstruct the image. After giving these signals to the our sorter, we can adjust the whole system on the basis of the brightness and others. एक बार ऊपर. So what are the different reviews or reports, some of the research papers which is analyze different machine vision system. So basically this is the very basic machine vision system where we are showing the some of the different light sources, and these light sources will give an light to the product and it will reflect back to the our cameras. The signal and the intensity of signal will capture in the cameras. Then it will analyze to a computer system. It is convert into the digital. First, it will analyze the signal, convert into binary code. Then it will analyze through the machine vision system. Same, we use the different texture characterization for surface images in a computer vision system and artificial neural networks. So these are the basics of the image processing system. Before that, we have to code whole variables into a system. Like we use this Skylab, Sci or MATLAB to conduct trial for the algorithms. Then from hit and trial methods, we can definitely get our deviation results. In some of the parameters, like if we are getting the RGB values, the Gaussian filters are used. It is the matrix created in the whole image system, which will analyze adjacent values. It transport filtered into a gray level image and obtain blue component image of the original image. Obtain the discrete Fourier transformation, which is showing the energy of the color values. With DFT obtain the phase from the U or B, the minimum and maximum gray level value of the B image. Now, it applies the OTVs, optical threshold values, which will analyze the segmentation of color between one to another. The different OTV values show the different initiation of color parameters that detect the boundaries in binary image and obtain the segmentation original image. So to in this system, we use the Sony cameras, and the difference between the other things and in this research paper, they use the 400 nanometer cut band filter, which will segment the whole image into the different categories and influence the visible radiations that will be coming through the our image illumination system, and the reflection come after into these cameras. So in dairy end, as food sectors. Some of the positions of the cameras and area analyzed will show by the Georgity in 2019, which proposed the approach for detecting skin color of animals at different temperatures. The sensor incorporated were an infrared thermal cameras and is developed. The script was developed in MATLAB. Same Vasnik and co-workers propose a model for detection of cow ghee using image analysis, where selected features like pixel intensity, branches, luminance, and equivalent diameters are calculated. These the cameras or the capturing system uses Canon Canoscan 9000F. Total 105 captures images be used, which is analyzed by the LAB mode. Mehdi Rashwati and co-workers use the machine vision with different hidden layers for differentiation in sesame oil with sunflower oil and canola oil. Actually, if the product are not mixable, we can analyze through the different layers of the machine. Different layer act as a different layers, and we can easily analyze through the different images. Then MATLAB are used for image processing for RGB, CMY, LAB color components for used for the studies. Same Vasnik and co-workers in 2007 extracted a particle count where CI lab is used and LAB was calculated. In this result, the particle count, luminance, equivalent particle diameter, and whiteness index can be considered for detecting level of vegetable fat in cow ghee, which is uh, high problems in nowadays in the ghees. The vegetable fat are completely mixing, and we can't analyze through the and the refractive index change is very minor. So these machine visions parameters will help to uh, take adulteration parameters in different products. So in 2018, Chang and co-worker sensitivity of Hunter and International Commercial CIEs is measured, where different viewing angles from every angle chain, the variation in temperature range is checked of milk beverages, where they get the sample measurement temperature should be specified along with type of illuminant. That the results is different in the every angles and with different illumination conditions. So the steps are in the system of RGBs, printing of color calibration chart, which we have seen earlier from 1 to the maximum values of the color system, where color measurement of calibration chart is done. Calibration program error and trend analysis is done. Then color correction algorithm is completed, and validation of by the physical parameters are completed. The calibrated color measurement of agriculture food using image analysis system is can show the RGB values. It will be increasing, but we can see that the variation in red color is R in high and G is low, and blue is similar to the uh, red in the initiation, and it get lower values after the 250 calorimeters. Same that it is showing the light effect of light independent of the position of the light, so related to the surface of the sample. The incident angle, if you are setting on the 45 degree, will it will get an same deviation from the cameras. If we are using the mirrors or holes, it will be get an straight image, and it comes in the cameras, and we can calculate through it. So uh, through these properties, we can analyze one of the texture segmentation. It is the GLCM, gray level concurrence matrix. So we converted the whole images into gray. Then the system or metric, the script will divide segment into the matrix like 3 by 3 and 4 by 4. If it is 2 raised to 4, it will convert into 4 by 4 pixels, which will be analyzed different properties. So what are the properties we have analyzed? We can analyze the different parameters. The first column show the contrast, correlation, cluster shade, dissimilarity, energy, entropy, homogeneity, maximum probability, sum of squares. This is the first order parameters, and second order parameter is sum of variance, sum of average, entropy, variance, difference in entropy, IMC1, IMC2, INV, inward difference normalized, and inward difference movement normalized. So like if we are analyzing the SD, standard SD, so image can be converted into the first one, and if we are analyzing the CV, the coefficient of variation, it will be converted into second. But we have to make the unanimous or homogeneous setup. Like you can see the whole image sectioned or segment in a 3 by 3 sections, so it can be compared. Same as angular second moment of homogeneity and contrast and correlation. We can make a script through these systems like MATLAB and Scilab. We have to give the formulas, like every single GLC parameters have the statistical formula which will be scripted in the MATLAB. Then we will get result according to image. The deviation will be covered into the image setup and it will be given results. We can compare the high CV what high coefficient of variation what shows, low CV what shows. We can calculate through the other statistical parameters. So how it is calculating? It is calculating like in the horizontal, vertical, and diagonal series. All these things compare each of every pixel from another pixel and gives result of the every 16 or 20 properties which will be scripted in your MATLAB system. So this is the one of the methods of to analyze one of the methods to analyze the machine vision system. So I will be conclude this with this method. So machine vision and image analysis systems have revolutionized the dairy and food sector by providing efficient and accurate solution for various processes where the processes are very hazardous and the human can go there. It's like in bioreactors, the corrosion we can't detect through the regularly inspecting the bioreactors. We can get an image continuously and we can be prepared when the bioreactors will degrade and what is the main time to change the whole bioreactor system. Same as in these systems have proven to be effective in ensuring quality controls, reducing wastage and enhancing oral products. With this is the main segment we are lacking in the food sectors, the quality controls. If an alarm or the high values of the systems will be set, we can reduce the wastage and we can enhance the overall product properties like the heavy metal contamination and other things. We can minimize it. With these abilities to detect defects, sort products, and monitor production, we can increase the economical things if we are getting the bright red color apples by using the some of the image analysis system in very short time, very short span. It will be very economical way to produce the premium products. These significantly contribute to the improvement of food safety standards. So machine vision and image analysis systems are capable of handling large volumes of data and performing complex analysis, enabling business to make informed decisions and improve their cooperation. So this is the helpful segmentation of machine vision and computer vision system. But we have to take this thing that these machine vision work on our data, how we are taking the things into our eyes and how we are getting the feedbacks. We are giving the feedback to the systems. What are the segmentation? What are the critical parameters we have feed? If we can believe the data, we can believe the computer machine vision system. So these systems are in our hands. How we will rectify our problems through these systems, it is based on us only. Thank you.
Thank you, Dr. Sumit Mehta, for this nice and informative session.
Thank you, madam.
Now the session is open for the discussion.